This calculus review is on differential equations and slope fields, growth and decay, half-life, population, bacteria, that kind of stuff. Okay, so we're going to start in Barron's 1, number 21. Barron's 1, number 21. Okay. Okay, it says if f prime of x equals 2 times f of x and f of 2 equals 1, then f of x equals. Okay, so take this and let's write it in terms of dy's and dx's and x's and y's. So f prime of x is dy dx. And that equals 2 times f of x. Well, f of x is the same thing as y. So times 2y. Okay, now this I can do something with. So I'm going to get my y's on one side and my non-y's on the other side. So I'm going to divide both sides by y. And I'm going to multiply both sides by dx. Okay, and then I'm going to integrate. So that's going to be ln of y. Technically plus c, but I'm going to put my plus c on the other side. And that would be 2x. And then there's my plus c. Okay, now I'm going to get it out of log form, so I'm going to e it or snail it. So, you know, your base is e, so it's going to be e to the 2x plus c equals y. Then it tells me that f of 2 is 1. So when x is 2, y is 1. So I'm going to plug those numbers in for x and y. So that'd be 4 plus c equals 1. Okay, now stop with the algebra and think logically. E to the something equals 1. Well, the something, the power, would need to be a 0. So what does c need to be for your power to be 0? C needs to be a -4. So again, don't get that tunnel vision on your algebra and your computation. Don't forget that logic can come in here and help out. Okay, so now I'm going to go back into this and plug that in. And it says find f of x. Well, f of x is the same thing as y, and that's what we got. Answer's A. So the first deal here was to change f prime of x to dy dx, and 2 times f of x to 2 times y. It just gives you more to work with, and it looks more normal when we're talking about differential equations. Okay, now we're going to Barron's 2, number 18. Barron's 2, number 18. Okay, it has to do with this slope field. This is which function could be a particular solution of the differential equation whose slope field is shown. Okay, now when you do these, you need to pay attention. Are your multiple choice answers y equals, or are they y prime? If it's y prime, then you need to look more at slopes. If it's y equals, then you need to use what you know about each function and figure out which graph would move through these slopes correctly. What I can see is that it's headed and then back up and then back down. Looks something along those lines. I know it's not x cubed because x cubed looks like that. And this function in no way, shape, or form looks like that. I know it's not sine because sine looks like that. Let's see, what else do I notice? I notice that all my slopes are the same on each vertical line. Everybody see that? That means that my y value don't matter, which means I shouldn't have any y's in my answer. Well, that doesn't help me. Again, because these are all solved. These are all y equals, not y prime. Let's see. I can see that I'm probably going to have a horizontal asymptote. I don't exactly know where because I don't know where this function is. Slope fields don't tell you that. They just tell you that if it's at this particular spot, this is how it would move through these slope fields. But it does look like I'm going to have a horizontal asymptote. To have that, let's see. Let's think about your degrees. If I'm looking at B and C, the top degree is bigger than the bottom, then I don't have any horizontal, and I need to have a horizontal. Well, this one's good. He would have a horizontal at y equals 0 because the bottom's bigger. And this one would have a horizontal at y equals 1 because the degrees are the same, so it'd be 1 over 1. Well, that could happen on either one. I could have a horizontal asymptote here, or I could have a horizontal asymptote here. Vertical asymptote. This guy does not have a vertical asymptote. In no way, shape, or form are all these slopes headed towards a vertical asymptote. Vertical asymptote is when you set the bottom equal to 0 and solve it. Well, if I take that bottom and set equal to 0 and solve it, I get no solutions, and the same thing there. So that doesn't help me at all. But that is a strategy that you can use. Okay, so when in doubt, I'm going to fall back on just a nice little chart. I'm going to plug some points in for B and plug some points in for C. Let's try, I don't know, let's try 0. Now at 0, when x is 0, I can tell that my slope, I don't know, it might be vertical. I don't know, let's see. Plug a 0 in, I'm going to get 0 over 1, which is 0, and the same thing for C, I'm going to get 0 over 1, which is 0, so that doesn't help me. Okay, so let's pick something, I don't know, like, let's go -3. Now look at your slope fields. Let me erase all this. At -3, you can see that we're headed in the negative direction. So at -3, my slope should be negative. Because you can see these slopes are headed slightly down. Okay, so let's plug in a -3 for B. That would be -6 over 10, and that would be a negative slope. So we're good. For C, that would be a +9 over 10, and that's a positive slope. So at -3, he would have a positive slope, and I don't have a positive slope. I have a negative slope, so it's got to be B. Okay, now we're headed to number 33. Okay. Bacteria in a culture increase at a rate proportional to the number present. An initial population of 200 triples in 10 hours. If this pattern of increase continues unabated, then the approximate number of bacteria after one full day. Okay, so the first thing that really needs to pop out in your mind is that that's 10 hours and it's asking for 1 day. So we're going to go all hours. So the 1 day is going to turn into 24 hours. Okay. Bacteria culture increase at a rate proportional to the number present. Okay, so you can either start bacteria increase, so you can say dy dx, like or dt. The increase in y is proportional to the number present. So the rate at which the number is increasing is proportional to the number present. And then you're going to divide by y and multiply both sides by t. And then you're going to integrate both sides. So that's ln of y equals kt plus c. And then you're going to snail it. So e to the kt plus c equals y. And then if you remember this, and this is just a constant, so we put it out front. Now, this should look familiar. And if you can skip from here and go straight to here, that's fine. But I just want you to see where you can come up with that. And again, this was the rate at which the number of them increase, so dy dt, because that's what's growing, is proportional to the number that we have. And then I just solved it. Okay? So now I'm going to take this. Okay, now it says that an initial population of 200 triples. Okay, so my initial population of 200 triples. So when time is 0, my initial population is 200, and I end up with 600. Divide both sides by 200. E to the 0, yeah, e to the 0, hold on. Yeah, sorry. If it tells you that your initial population is 200, then you know what C is. So C is 200. I'm sorry. Okay, now, what I'm going to do is I'm going to use the fact that it triples in 10 hours to find my Y. That's what I wasn't doing. Okay, so I'm starting with 200. I'm going for 10 hours, and it's going to triple. So now I can solve for K. So e to the 10K equals 3. Okay, and then I'm going to ln the 3 and get 10K. So that's the snailing it part. Divide by 10. And I get K to be 0.1099. Make sure that you can type this in to your calculator and that you're comfortable with that. Okay, so now I'm going to take this K and I'm going to put it right there. So 200 E to the 0.1099 T equals Y. Okay, now what it wants is how much do I have after 24 hours? Well, I've got my C and I've got my K, so now all I have to do is plug in a 24 hours in for my T. So 200E, 99 times 24. Okay, so pause the video, plug this into your calculator, and make sure you get, I got 2795.922. So pause it, plug it in, and make sure you're good. So let's see if we pick the closest answer. We're going D. All right, so that was number 33. Now we're going Barron's 3, number 9. Barron's 3, number 9. This one's crazy, crazy easy. It says a particular solution of the differential equation whose slope field is shown above contains point P. And this one's P. So again, we don't know how the function moves through the slope field, but they're telling us that whatever the graph looks like, it goes through this particular green point. Okay, and then it says this solution may also contain which other point. Well, if I have to go through point P, this green dot, am I ever going to swoop down here and get A? If I follow this slope field, will I swoop down there to A? The answer is no. It's going to turn me, it's like a current. It's going to turn me northeast way before I can ever get to A. Now, if I was a point like over here, then yeah, I could potentially swoop down and hit A, but not if I have to go through this guy right here. So A's out, C's out also, and so is D. And then if you really look at it, B's out too. If I follow the current, and again, think of this like a current. If I follow this current, then it's super, super obvious that you're going to hit E. So very nice, little easy start there. Okay, so now we're headed to number 12. A smooth curve with the equation y equals f of x is such that its slope at x equals x squared. The slope at each x equals x squared. If the curve goes through the point -1, 2, then its equation is. Okay, its slope. Okay, well, slope is y prime, right? Its slope at any point is y prime. So the slope at each x equals x squared. Okay, so my slope, my dy dx, equals x squared. Okay, now stop for a second, make sure that makes sense. A smooth curve with an equation, y, is such that its slope at each x, that's the definition of a derivative, equals x squared. So dy dx equals x squared. Okay, so now all I'm going to do is I'm going to separate my variables, multiply both sides by dx. I'm going to integrate. Okay, so I'm here, which is great. And it kind of sort of looks like some of the answers. Then I need c. So it's going to give me a point, -1, 2. So I'm going to take the 2 and plug it in for y. And I'm going to take the -1 and plug it in for x. Okay, so then I'm going to add 1/3 over. And that would be 6/3, so 7/3. Okay, so if I go back here, I have y equals 1/3 x cubed plus 7/3. Okay, so it's not A, really close to being B, but it's not. Okay, now if I look at C and D, well, D is solved for y. No, not D. Okay, so now if I look at C and E, those are the two I have left. They are both equal to 0, and they have no fractions. So these are just more hoops that they're making me jump through. So first of all, no fractions, and then second, it has to be equal to 0. Okay, well, for the no fractions part, I'm going to multiply by 3. So 3y equals x cubed plus 7. Okay, so no more fractions. But I also need to get everybody on one side, and who do they want? C has the x in the front, E has the y in the front. E also has this weird 5, and I don't have a 5 in my answer. So I'm going to see if I can head towards C. C puts the x in the front, so let's try it. So if I subtract him, leave him, and subtract him, so how are we different? All of our signs are different? Well, I can run through with a negative and let the 0 eat it. There we go. Now, in doing these reviews, I have noticed that problems like number 12 pop up a lot. So be just super comfortable with setting up your derivative, separating your variables, taking the integral of both sides, taking a point, plugging it in, find your C, that whole process. Okay, so that was number 12. Now we're headed to number 32. Number 32. And this is calculator active. Yay. Okay, a cup of coffee placed on a table cools at a rate of per minute, where H is the temperature of the coffee. Okay, so that makes sense. So this is dHTT, so that's the change in the temperature. And T is in minutes. If the coffee was 120 degrees initially, what's the temperature 10 minutes later? Okay, so the change in the temperature, and H stands for temperature. I'm going to drop the degrees Fahrenheit. And T is in minutes, so we're good there. Okay, so I'm going to separate my variables. I'm going to divide this piece right here over, and I'm going to multiply this guy right here over. So dH over h minus 70.05 dt. Okay, so now I'm going to integrate. Think about this like u substitution. U would be h minus 70. U prime would be 1. So this is u prime over u, which is ln. And this would be a negative 0.05 t plus c. Okay, now I'm going to get rid of my ln. I'm going to e it. So e to the negative 0.05 t plus c equals h minus 70. And again, we can use that trick where we write that as e to the this times e to the c, and e to the c is just a constant, so the c just comes out. Kind of use that trick a lot. Okay, so I'm here. Now, it says initially 120 degrees. So here's what that means. When t is 0, h is 120 degrees. So I'm going to know him and know him. This is going to allow me to find c. So ce to the negative 0.05 times 0, 120 minus 70. Okay, well, e to the 0 is going to be a 1, so that's going to be c equals, and 120 minus 70 would be 50. Okay, so now I know him. So 50 e to the negative 0.05 t equals h minus 70. Okay, so now I have t and h are my only variables, and it says, what's the temperature in 10 minutes? So all I've got to do is plug in a 10 for my t. Okay, so you're going to type that whole piece in, and then you're going to add 70, and that should give you h. Your answer is 100 and some change. So pause the video, type that in, make sure you're good. And the answer is 100. But again, everybody type that to make sure that you're good. Okay, now we're headed to number 33. An investment of $4,000 grows at the rate of that dollars per year after 2 years. I want to know its value after 10 years. Okay. This is interesting. They're making you work for this one just a little bit. So think, I have $4,000. That is my principal. It is growing. It is changing at this rate. So dp dt equals 320 e to the 0.08 t. Okay, I'm going to separate my variables. I don't have any p's to move over, but I am going to multiply both sides by dt. So dp e to the 0.08 t dt. Okay, and then I'm going to integrate this part, sorry. So p equals, okay, the 320 is really just kind of hanging out. Now this is e to the 0.08 t. So that part, when you take the integral, that part stays the same, but you do have to multiply it. No, no, I'm thinking derivative. All right, back up. All right, we got to go use substitution. If u is 0.08 t, u prime is 0.08. So I need a 0.08. So I have to give it a 1 over to compensate. So now I have e to the u prime. Make sure you understand that. I know it's decimally, which makes it ugly, but like if you had that, then your u would be a 5t and your u prime would be a 5, so you'd need a 1/5 out front. Okay, so that's what I'm doing. And then e to the 0.08t. And this would be e to the 5t. Okay, so now I clean. Oh, plus c. Always forget that plus c. So let's see. That's 4,000 e to the 0.08t plus c. Okay, then it says, let's see, I'm here. I need my c. So it says initially we had $4,000. So I had $4,000 when time was 0. Okay. E to the 0 is just going to be 1 times 4,000 will be 4,000. Subtract 4,000 over, C equals 0. So now I have P equals 4,000 e to the 0.08t plus 0. So I'm not going to write it. And then it says, what do you have after 10 years? So I'm just going to plug a 10 right there. Type that into your calculator. I know it's money. I still went 3 decimal places just because I wanted to compare it to their answer. Type that in with the 10. Make sure you get this. 8902. Yep. There you go. Okay, so that was number 33. Okay, so now we're headed to Princeton 2, number 42. So we're skipping Princeton 1. We're going to Princeton 2, number 42. Okay, it says the volume of a cube is increasing at a rate proportional to its volume at time t. Okay, let's stop there. The volume of a cube is increasing. Okay, so what does that mean? That doesn't mean V equals something. That means dV dt. The volume is increasing at a rate proportional to its volume. Okay, so now I'm going to split my variables up. So I've got a V I need to divide over, and a dt I need to multiply. And then I'm going to take the integration of both sides. So that's going to be ln of v equals kt plus c. Okay, then I'm going to snail it. So e to the kt plus c equals v. And again, this, well, that's a t. This plus c, you can use your power rules, and I'll write it out just so you can see it. Because when you add, it's the same thing as multiplying. And then this is just a constant, so he can come out front. So again, we kind of have this exact same setup that we've had. Okay, so now it should, let's take some information. The volume is originally 8. Okay, when it's in this nice setup, your C is going to be your original volume. But if you remember back from the $4,000 problem, we started with $4,000. Our C was not 4,000 because it was not this setup. So if you're iffy, if your volume is 8 feet originally, then leave your C. Your T is 0 because you're original. And your volume is 8. Well, the 0 wipes out the K. It takes the E to the 0, makes it a 1, so C equals 8. So you can see that your C is 8. So now I can plug that. Okay, so I've got my C. Now I need my K. So now it should give me a time and a volume. And it does. It says 12 after 5 seconds. 5 seconds, volume's 12. I'm going to divide by 8. 3 over 2. And then I'm going to ln it and snail. And then I'm going to divide by 5. Type that into your calculator. Make sure you're good. 0.0811. So now I have my K. All right, so I'm going back here. I know my C. I know my K. All right, so now you give me any time I can tell you the volume, and it says time is 12 seconds. So I'm going to put a 12 right there. Type that in. You should get 21.171. But type it in. Make sure you're good. 21. Going to go with A. Okay, that was 42. Now we're headed to Princeton 3, number 45. Princeton 3, number 45. A radioactive isotope Y decays according to that equation, where K is a constant, T is measured in seconds. The half-life is a minute. Find K. Okay? So it's saying that the change in Y is proportional to Y. Okay, I'm going to separate my variables, divide my Y over here, multiply by dt, integrate. That's ln of Y, kt plus c. This should really start to look familiar by this point. So we're going to snail it. E to the kt plus c equals y. Use your power rules, pull your c down. Okay, so here we are. Now it says the half-life is a minute, but if you read super careful, it says that t is measured in seconds. Okay, so what this means is that when t is 60 seconds, whatever this is going to be half of it. And so, you know, you can pick some numbers and say, okay, if we started with 100, this is now 50. Well, if you divide your C over, it's going to give you a half. If you started with 50, then this is going to be 25. Again, if you divide the 50 over, you're going to get a half. So what you can do here is e to the kt equals 1/2. Take a second, make sure you see what I'm doing here. And then the t, you know, is 60 seconds for it to reach half. Okay, so now I'm going to ln with a snail. So ln of 1/2 equals 60k, and then just divide by 60. Negative 0.0116. Negative, obviously, because it's decreasing, so it makes sense that it's negative. So we're going to go there. Okay, so make sure you're cool with that 1/2. And now I just made up numbers. If I start with 100, then after 60 seconds, I'm going to have half that, 50. And then if I divide both sides by 100, this value over here is going to be a half. If I started with 50, I'm going to end up with 25. Divide the 50 over, I still have a half. So it doesn't matter what your C is and what your Y is. The point is that when you divide it over, you're going to have a half because it's a half-life. Okay, so now we're headed to extra. The extra practice number 25. Extra practice number 25. The general solution of the differential equation, that thing, is a family of straight lines, circles, hyperbolas, parabolas, and ellipses. Okay, well, if it's a straight line, we are y equals mx plus b. If we're circles, we have an x squared and a y squared. They are both positive and they have the same coefficient. An ellipse is an x squared and a y squared. They have to both be positive, but they have to have different coefficients. That's what makes it longer one way than it is the other. A hyperbola, you're going to have an x squared and a y squared, and one of them needs to be negative. It does not matter which one. A parabola, you're going to have an x squared or a y squared, but not both. All that's from pre-cal. So dy dx. Okay, so I'm going to separate my variables. So I'm going to multiply by y. Okay, then I'm going to integrate. So 1/2 y squared x minus 2, 1 x squared. Okay, now let's look. It's definitely not a straight line. I do have an x squared and a y squared, so it's not a parabola. Now, currently, one of them is positive, one of them is negative, but they are on opposite sides of the equal. So if I got it all on one side, then I have an x squared and a y squared, both positive, different coefficients. Ellipse. That's a nice problem. Okay, so now we're headed to 38. Thirty-eight is nice and easy. Again, when you have slope fields, pay attention to your y equals. Okay, so we're looking at number 38. I notice that these are all y equals, not y primes. So I'm looking for function, not slopes. Okay, well, guys, look at this. You can see we're coming in. Oh, hang on. Coming in, swerving up. Which one of these graphs look like that? Super easy. That one you should know. Nice. Love those. All right, now we're headed to number 40. Another slope field. Okay, now these are y primes in your multiple choice. So now I'll be looking for slopes. Okay, so in looking at slopes, first thing I'm going to look and see is I see that all my slopes are the same going vertically, which means the y doesn't matter. So I don't want a y in my slope equation. Okay, that was easy. Let's see. I'm also going to look and find interesting things that stick out. I'm looking for zeros and undefined. I don't see any zeros. I don't see any horizontal slopes, but I see a slew of undefined slopes. And this is where x equals 0. So which one of the three left, if x is 0, causes it to be undefined? Right there. Nice, number 40. Okay, so now we're headed to 75. We only have 2 left. 75. Okay. 40 grams of a radioactive substance decomposes to 20 grams in 2 years. Okay, now notice that's a half-life. Then to the nearest gram, what is the amount after 3 years? Okay, so I know that his half-life is 2 years, because that's how long it took him to only have a half left. Guys, at this point, I'm just going to skip straight to this. Half-life, so this is 40. No, we started with 40. This is 20. Started with 40 and went for 2 years. Again, divide the 40 over. There's that half that I was talking about earlier. Solve for K. So I'm going to ln. And then divide by 2. Type that in. Make sure you're good with typing that in. These we want to get right. So take your time. Type that in. So now I know that y equals, started with 40, e to the negative 0.347t, and I want to go 3 years. So I'm going to plug a 3 right there in front of my t. So pause this, type that in with a 3 in your time, and you should get 14.124. So we're going 14. But again, pause, type it in, make sure you're good. Okay, the last one we're going to is number 83. This is a really good one to end on. He follows in line with the process that we've been doing, but he's got a little extra stuff going on that we just want to make sure that you know how to deal with. Okay, so in a protected area, no predators, no hunters, the deer population increases at a rate of, okay, now notice it's dp dt. P is the population, so it's the change in the population. It's increasing. There's your constant K, 1,000 minus P. Again, P is the population of deer. T is your years. If 300 deer were originally placed in the area and a census showed the population had grown to 500 in 5 years, how many deer will there be after 10 years? I love that it says there was a census shown, like they mailed them a census and had them fill it out and mail it back. That's just funny. Okay. So dp dt 1,000 minus p. Okay, I'm going to separate my variables, so I'm going to divide by 1,000 minus p, and I'm going to multiply by dt, and then I'm going to integrate. Okay, now be careful. Normally we can do this real quick, but our u is 1,000 minus p, so my u prime is a -1. Normally it's just a 1, but this one's a -1. So this is still u prime over u, so it's still going to be ln of u, but I have this negative that I have to create. So it's negative ln of 1,000 minus p. And that's going to be kt plus c. This negative right here in front of my ln bothers me, so I'm going to kick him. I'm going to divide everybody by negative and kick him over to the other side. I'm still going to leave my c positive because it just stands for a constant. Okay, now I'm going to snail it with my e, so e to the negative kt plus c minus p. And again, you know what you can do with that c right there. Okay, and then if you wanted to, you could, formally solve this thing for p. So if I moved the 1,000 over, but then that would be a negative p, I'd have to change all my signs. So however you want to do this, the 1,000 is going to end up to be positive, and the c is going to end up to be negative. Just think about the algebra behind that. Just nice and easy. Okay, now it says my initial population was 300. Yeah, 300 deer were originally placed in the area. Normally, that's just my C, but this guy's not normal. He's got this extra stuff going on. So let's say, okay, if I have 300 deer when time is 0, and let's solve for C. Okay, e to the 0 is going to be 1, and 1 times c would just be c. And then if I subtract the 1,000 over, that's going to be negative 700 divided by the -1. So c equals 700. Okay, so now I'm going back here, and I'm going to put my 700 right here. So I have p equals 1,000 minus 700 e to the negative kt. I still need k. Okay, now it tells us that the population had grown to 500 in 5 years. Okay, so I have 500 deer on year 5. Subtract my 1,000 over. Divide my 700 over. And then I snail it with my ln. And then divide by -5 to get my k. Everybody type that in. Okay, so now I know my k. Okay, so again, I'm going back here. I knew my c was 700. My k is negative because the deer population is decreasing. Okay, now it says, How many deer are you going to have after 10 years? So I am going to plug a 10 right there for T. Okay, so pause it, type it in. 1,000 minus 700 e to the negative 0.0673 times 10. And you should get 877. 642-ish deer. Let's look at our choices. Gonna go 643. So again, I mean, that problem took some work, but it's just a jacked up version of what we have been normally doing. So just, be prepared to handle a curveball when they throw you one. Okay, your homework for this. Let's see. Barron's 1, number 9. Barron's 2, 43. Princeton 1, 24 and 40. Princeton 2, 28. And the extra, 35. That's not bad. Again, guys, the point isn't for you to sit here and slave over these problems. The point is for them to be coming back to the front of your brain and for you to be able to handle these when you're presented them on the AP test.